Hello, my name is Bryan Kirk, and I'll be doing this presentation with Nikhil Virani. We both do research in Dr. Meyer's lab in the chemistry department. And our research is on the fibrillation of a protein called alpha-synuclein, which is important because alpha-synuclein is implicated in Parkinson's disease as the major protein in Lewy bodies. Lewy bodies form when alpha-synuclein monomers, as you can see in figure 1, begin to aggregate and form nuclei, which then with the addition of more monomers form oligomers, and then finally form the mature fibrils, which we see in the Lewy bodies.
And so in fibrillation, there's a three-step process to the aggregation process. So the first step is the lag phase, as you can see in the bottom of figure 1. And the lag phase is where protein monomers assemble to form aggregation nuclei. The second phase is the elongation phase, where the fibrils grow exponentially and the monomers start to clump together. And then the third phase is the stationary phase, where the depletion, where there's no more monomers, and that leads to a decrease in the growth rate. So in this experiment, we wanted to test the effects of certain crowding agents, which mimic the intracellular environment on the rate of alpha-synuclein.
Before we began the fibrillation experiments, we had to purify alpha-synuclein from E. coli. In figure 2, you can see the results. We induced production of alpha-synuclein in E. coli cells, and the positive shows cells that did produce the protein, and the negative shows cells that did not produce the protein. And then as we proceeded with the purification, we did boiling and precipitation. And then in figure 3, you see the results from our anti-exchange chromatography, where the first peak represents alpha-synuclein, and the second peak represents the nucleic acids, which we were able to separate from the protein. Then in figure 4, you see the results from our size exclusion chromatography, and the largest peak represents alpha-synuclein, which we were able to separate from other anions or other ions in solution. Then figure 5, we used UV absorbance to show that we had alpha-synuclein, and this is a very characteristic UV absorbance spectrum for our protein. So we used absorbance at 280 nanometers to calculate the concentration of our protein in the sample with Beer's law, and our final concentration was 14.4 milligrams per milliliter. When we began the fibrillation experiments, you can see in figure 6, with the BK protein, we don't see a stationary phase. The fibrillation just continues. And so this was a problem which prompted us to, in figure 7, check the purity of our protein sample, which you can see the BK protein has more impurities below the about 14.5 kilodalton alpha-synuclein band. And we believe that this could be causing the extension and no stationary phase.
So fibrillation of alpha-syn was induced by incubating it at 37 degrees Celsius with mechanical agitation by spinning the protein samples at around 307 circular orbitals per minute. And we used thioflavin T and a microplate reader to monitor the fibrillation of the protein. And so in figure 9, you can see the curve fits for all the alpha-syn samples that were in buffer solution. And then in table 1 were the half-life, K-value, and lag phase times for each buffer from figure 9. And figure 10 was the curve fit for alpha-syn with using sucrose as a crowding agent. And in table 2 was the half-life, K-value, and lag phase times for the sucrose samples in figure 10. As you can see, half-life and K-values were calculated by using the formula in figure 8. And then lag phase time was calculated by taking the half-life and subtracting that by 2 divided by the K constant value. And so we can see that the fluorescence data shows that there is a lag phase, elongation phase, and a stationary phase that occurs throughout the fibrillation process. And overall, it appears that the K values are smaller in sucrose and the lag phase is longer in sucrose than buffer solution. So in conclusion, we can conclude that alpha-syn was overexpressed in E. coli and purified, and the identity of the protein was confirmed by UV absorbance. Our sample may contain some alpha-syn proteolysis products like in figure 7. Crowding does affect fibrillation. However, we're not sure how it affects fibrillation. And the plate reader gives us more reliable data than our old method, which was fluorescence spectroscopy, but more work needs to be done.